In this problem, we have two equations and we're just going to write it in rectangular form. We want to have it look like y equals some equations, so we want to eliminate t in here. You take this equation for the x and you solve it for t. X is equal to t squared plus 2. I subtract 2, and that equals t squared. Now I'm going to take the square root of both sides, and I'm going to take the positive one. T is equal to root x minus 2. Okay. I will take this now and put it into my equation.
Is there a reason why you took the positive?
For y. Yes, we want the positive values for t.
Wait, would it be minus 2? So I said it's plus. I thought I saw you break the last one.
So if y is equal to 2 times t, then y is equal to 2 times the square root of x minus 2. This is how we combine two equations into rectangular form. All right, meaning x versus y. Yes?
But wouldn't it be negative x minus 2?
No, because you subtract 2, so it's x minus 2, and then we take the square root, and we want the positive values for t. All right, this is a similar problem. We're going to write x and y in rectangular form, then graph the equation. I'm going to take this equation again, and I'm going to solve it for t. When I square both sides, I get x squared is equal to t plus 1. X squared minus 1, therefore, is equal to t. Now I can take this and plug it into my equation for y. So y is equal to 1 over 2t. That means y is equal to 1 over 2 times x squared minus 1. This is the equation in rectangular form.
Do you not want us to like distribute the two?
You don't have to distribute. Now, it says state the restrictions in the domain. In this case, the denominator is going to equal 0 for which points? X equals 1 and x equals negative 1. Therefore, the restrictions are that x can't equal 1 and x can't equal negative 1. When you don't have to distribute. You can, but you don't have to. In either case, the restrictions will be the same. It'll be x equals 1 and x equals negative 1.
So how do we show that on the graph?
Well, if you have an equation like this, and x can equal 1 and x can equal negative 1, that means those two are asymptotes.
Got it.
Now, to graph this, we're going to pick points. We're going to graph it as x versus y. So for x, I'm going to pick negative 3, negative 2, 0, 2, and 3. Okay? When x equals negative 3, I believe I get 1 over 16 for y. When x equals negative 2, y is positive 1 over 8. When x is 0, y is equal to negative half. When x is 2, it's symmetric. It's 1 over 8. And when x equals 3, it's 1 over 16. Yes?
Isn't it negative 2, 6? 1 over 6.
Is it 1 over 6? 1 over, this will be, it is 1 over 6. Okay, so I have 1 over 16, which is a very small number. 1 over 6, it's also a very small number. Here I have when x equals 0, y equals negative half. And here it's symmetric. All right, now I have asymptotes here. And you can check this on your graphing calculator. If you graph this, this is going to look like this. All right? And as we know, if the graph exits the screen on top here, then it'll re-enter here. This leaf is going to be the same. So again, if it exits on top here, it'll re-enter here. That means the bottom portion will look like this. You're more than welcome to double check this on your graphing calculators.
Wait, so it's negative a half?
Right.
Oh.
How do you know that there's an asymptote at 0?
Well, when you graph it, you will know. But also remember, anytime you have a rational function, you have possibilities of asymptotes. So remember, this would have been 1 over 2x, if you remember from 2 chapters ago or 3 chapters ago. How to find horizontal asymptotes. Y equals 1 over 2x squared, and you can use that. Okay. Let's take a look at this problem.
Can I graph it? It looks different.
Try it again. It should look
Go back.
very much the same. So this is a similar situation. You have two equations in x equals 3 cosine theta, y equals 5 sine theta. Now our parameter is not t, it's theta. So the one that we want to get rid of is theta if we want to write it in rectangular form. So again, I want to have this in terms of x and y only. What I'm going to do is I'm going to solve each of these for the trig functions. This one will be cosine of theta is equal to x over 3. Okay? So I solve for cosine of theta. If I solve this for sine of theta, what will that equal to? Y over 5. Now, I have sine and cosine. And if you recall, there is a trig identity that connects sine and cosine. What's that trig identity? Sine squared theta
Plus cosine squared theta
plus cosine squared theta is equal to 1. Now, sine of theta is y over 5. Sine of theta squared is y over 5 squared. Plus, cosine of theta is x over 3. If you square that, it'll be x over 3 squared is equal to 1. So finally, when you distribute the square, it'll be y squared over 25 plus x squared over 9 is equal to 1. Now, what is this? What is this an equation of?
Ellipse.
Oh.
It's an ellipse. We know it's an ellipse because the x is squared, the y is squared, both are positive, it equals 1. Now we have to graph this. And we can graph this very, very quickly using all the shortcuts that are available to us. A in this case is equal to 25. What is B?
Wait, isn't A 5? Because
A is equal to 5, yes. And what is B?
3.
3.
What is going on? I think you got the gravity curve.
And B equals 3. Okay, it won't seem to cooperate. We'll put them up here.
And
A equals 5, B equals 3. We don't need the focus to graph this one. So this is going to be horizontal or vertical?
It's horizontal. No,
It's a vertical ellipse because the bigger one, A, is with the
Why?
y. So A we said was equal to 5 and B was equal to 3. Alright, the center is at 0, 0. If A is equal to 5, that means I have a vertex here and another vertex here. If B is equal to 3, that means I have a co-vertex at -3 and +3. And the ellipse looks like this. You don't put the foci, you don't have to, but what we do have to do now is we need to fix the orientation, or we need to note the orientation. Now, our parameter here is theta, okay? So let's pick values for theta.
Pi.
When theta is equal to, let's pick the easy ones, pi over 2. All right? Remember, it goes from 0, pi over 2, pi, and so on. When theta is equal to pi over 2, what is x equal to?
Yeah.
X equals 3 cosine pi over 2, which is 0. Y equals 5 sine pi over 2, which is 5. Okay? So when x is 0, y is 5, this is when theta is equal to pi over 2. What if when theta is equal to 1? When theta is equal to pi. This time, x is equal to 3 cosine pi. How big is that? -3. Y is equal to 5 sine pi, 0. So at -3 and 0, theta is equal to pi. All right? My graph is here at pi over 2, here at pi. That means the orientation of this is this way.
Counterclockwise.
Counterclockwise. Okay, that's how you fix the orientation.
Label those two.
Right.
Not the other.
All right, for projectile motion, we're going to use these formulas for x and y. I just have to mention that this value is actually 13 feet. It's supposed to be consistent with this. So a basketball player releases the ball at an angle of 53 with an initial velocity of 24 feet per second. This is the configuration of the basket. The hoop is here, 10 feet above the ground, and the center of the rim is 10 feet away from, or the rim is 13 feet away from the player. We want to see if she's going to make the basket. Yes?
Are we taking into account air resistance?
No. We're using these values. Okay? Remember that all this is in feet. Okay, so what is the equation for x? It's t v naught means initial velocity cosine theta. Okay? So let's see everything that we have. X is equal to t. We want the variable t to be in there. Initial velocity is 24. Cosine theta is cosine of 53. Now, y has a equation that looks like this. T times v initial sine of theta minus half g is acceleration due to gravity, t squared plus initial height, h naught, initial height. All right, y is equal to t. Initial velocity is 24. Basically, I'm given the equation, and I'm just putting in the given. That's all. Sine of 53. Now, minus half. I know you're used to 9.8 meters per second for g, which is the correct value. We're working in feet here. All right? 9.8 meters per second converts to 32 feet per second squared.
Wait, we're used to what number?
9.8.
Acceleration due to gravity is 9.8 meters per second squared.
We have to know that.
I didn't know. You have to
No.
know that if not physics.
For physics, you need to know that. Plus, what is the initial height?
10 feet.
4.75.
Huh?
The
Oh,
initial,
her and
the initial height of the ball, not her of the ball. Okay?
you know what I meant. Her
Now,
and the ball.
what we're going to do is, with your calculator, you're going to graph the equation for y, and you're going to get a parabola. Okay? You're going to get a parabola that faces down. Alright, so you just plug it in the calculator and you graph it. And when you graph it, the parabola looks like this.
Do you want us to put t
Right, so when you're
Yeah.
plugging it into the
So is it X
calculator,
cosine?
for the purposes of the calculator, it'll be x 24 sine 53. Okay, but just keep in mind that that's t.
is that multiplied by 1/2 or minus 1?
Minus 1/2 times 32. Okay, so this is what it looks like. Now,
Minus 16.
okay, plug it in your calculator later. Right now, just take my word for it. This is what the equation will look